Hello, so here is a walkthrough of how to do a two-column proof in geometry. For my students, this is day 4 of using a two-column proof to accomplish a goal such as proving that a triangle is congruent to another triangle. On a question like this, we're going to begin by laying out some statements and reasons from what has been given to us. So we'll start off by listing the given information, and we'll show that not only in the statements, but we'll also show it in the picture itself. This is saying that AB is parallel to DC. You can see that I labeled that with arrows, saying that these two segments are traveling in the same direction. It also says that AB is congruent to DC. So I indicated that with a single slash as a decoration on those two sides. I'm trying to prove that these two triangles are congruent. So what I want to get is information about both of these triangles. And I'm looking to either show that all three sides of one triangle are congruent to all three of the other, or that there's a side angle side congruency, an angle side angle congruency, or an angle angle side congruency. So I'll begin by listing those given facts, and you can either think about these facts and reasons that are located on our little fact sheet to try to come up with some other facts that you think would be helpful to list and the reasons why they are congruent. So I'll start off by picking on the first statement that there are parallel segments. I know from my experiences that when I've got parallel segments, I also have equal angles. In fact, this angle here is the same as this angle over here. So I can label that angle is the same as that angle. And I know that those are called alternate interior angles and they have to be congruent. You can find that on my fact sheet that you received this week. If you look around, there's popular reasons here for why things are what they are. And when we see parallel segments, be prepared to say that parallel segments make alternate interior angles congruent, or possibly that they make corresponding angles congruent. So for this example here, that's what I listed. Is that those two angles in blue are congruent to each other because parallel lines make alternate interior angles congruent. Remember, I'm shooting for one of our congruency reasons: side, 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 angle, side, angle, or angle, angle, side. And when I see what I've got so far, I've got a side and an angle matching a side and an angle. I think I just need one more piece, and the two triangles are glued together by the side AC. So to me, I think, oh, it's quick and easy. It's a quick, easy way to get one extra piece. It's also mentioned in this fact sheet that when you see two triangles sharing a side, be prepared to just say the reflexive property that those sides are equal to each other. It's our way to get that final piece so that we can complete our proof. So I did that. I listed that, and I'll just do a little check here. So I've got in my picture a side and an angle and a side matching a side, an angle, and a side. So I can state that the triangles are congruent because of side, angle, side. And move on to the next part of the question, which is to describe a transformation that justifies that the triangles are congruent to each other. So this is just taking you one step forward by reviewing something that we covered before, is what type of transformation could make one triangle become the other. And it says to be specific. So the rigid motions I'm thinking of are either a reflection, a rotation, or a translation. And you might know it by looking at it, that one triangle has been turned upside down on this point here on the diagonal AC. So that point right there is the midpoint of AC. And if we rotate that first triangle 180 degrees, it becomes the second. So the transformation I'm looking for would be a rotation of 100 degrees, 180 degrees, centered at the midpoint of AC. All right, let's move on to the next one. All right, so these are quicker fill in the blank sort of proofs. If you're watching this for the first time and we're not in class, give this a try. See if you can fill in the missing information. Remember, you also get this sheet here to help you along as well. My students have a copy of that on Schoology in the weekly folder. And I'll hold it here in case you want to take a screenshot of it if you're working from home and do not have access to my Schoology account. All right, I'll show you the answers to that. All right, so in each of these questions here, we used a congruency statement to justify whether or not the triangles are congruent. And in this one here, they started us off with two sides, the yellows and the greens that were congruent to each other. And I had to fall back on the idea that if the two triangles share a side, sure, just like the last one, I can actually use the reflexive property to say that MP is congruent to itself. And that gives me my third piece that I'm looking for. I'm even keeping track of the pieces that I'm gathering right here. It's kind of a scorecard of where I'm going. On this next one here, this was not side, it's side, angle, side. We were only given one side to start off with, the sides labeled with the blue decorations. They also gave us information that C was the midpoint of AD. Now you may know that midpoints make two congruent segments. If you were not aware of that, you can use the fact sheet here to find that sort of fact. If you're ever given a midpoint as a statement, be prepared to say midpoints make two congruent segments and then name the segments, which is exactly what I did. I saw the word midpoint there, and whether I thought it or I looked it up on that table of information, midpoints make two congruent segments, and then I went in there and named the segments. So C is the midpoint of AD. That must mean that AC is the same as DC. Then you can see that I actually had to use one other fact that wasn't mentioned in the given information. When you see two lines intersecting, forming four angles, be prepared to say that the vertical angles are congruent. Something you always have to be on the lookout for is using the reflexive property when two triangles are sharing a side or an angle, or the vertical angles when you see two lines intersecting. And then this would be showing a side angle side pattern. The little fact about the vertical angles is also on our formula sheet or our fact sheet here. When you see two lines that are intersecting, be prepared to say that vertical angles are congruent. That might very well help you get that final piece that you're looking for so that you can get that hat trick of finding three matching pieces. Okay, on to the last question. Question 6. You can pause the video and give this a try on your own, listing all the information, but I will show you the solutions after you unpause. Let's take a look to see what I wrote. Well, here's the entire question worked out from start to finish. And here's an explanation of how I did and how I knew what to write, what I did. So I started off by listing the given information, and I'm going to pick on the givens in the order that they were handed to me. It said that ABD was an isosceles triangle. And it says the vertex angle was ABD. So that's the top of the isosceles triangle. And the two sides that make up the vertex angle are definitely equal to each other. That's what makes a triangle isosceles. You can find that on the formula, or not the formula sheet, I said it again. You could find that on the fact sheet right here, that when you're handed an isosceles triangle, be prepared to say that there are two congruent sides. Also be prepared to use the fact that there are two congruent angles. So an isosceles triangle is a useful fact because we can get sides when we need them, and we can get angles when we need them. Okay, looking at what I wrote down that those red sides BA and BD are the same size because isosceles triangles have two congruent sides. All right, the next fact that I was handed was that BC bisects angle ABD. All right, there are two types of bisectors in this world. There are segments that bisect segments, and there are segments that bisect angles. Here it's a segment. See the segment symbol? Bisecting or cutting an angle. So find the angle ABD, and bisectors will slice an angle in half. So I know that that angle there is the same as that angle there, and I have to write about it. So I'd use three letters to describe it. Angle ABC is congruent to angle DBC. And the reason is because an angle bisector makes two congruent angles. You'll see that I've given you that fact here too on the fact sheet that you can use. When you're given a segment cutting an angle in half, you should be automatically ready to tell me what angle bisectors do. That angle bisectors make two congruent angles, and then tell me who the angles are. This sheet here of all these ideas, all these facts and reasons does not have any pictures. It's just kind of a general idea of what you would do when you run into certain facts along the way. And if we're keeping score of what I've actually figured out so far, it looks like I have a good start. I've got a side and an angle matching another side and an angle. I can use the reflexive property, just like in the other examples, to get that one final piece so that I can say that the triangles are congruent by side angle side. The last part of the question asks to name the transformation that will justify that one triangle is exactly the same as the other. So what rigid motion would preserve the size and the shape? So this has not been rotated to turn this one into this one. The original triangle has been reflected. So the answer is reflection, but if you want to be more specific, and you should, it's reflecting triangle ABC over segment BC. And it looks like I timed it just perfectly because the bell's about to ring. Hopefully this was helpful for you, whether or not you were in class or not. If you're missing some classes here, this is a good opportunity for you to see what you missed out on. And if you've been coming to class, it gives you an opportunity to hear it once again and to relive all the good times. So having said all that, have a great day and continue to work really, really hard and doing your best.